So today we are going to look at what's called linear programming, and this is actually lesson 2-4. So make sure you change that. So I'm just going to go ahead and help you fill out the blanks here. So linear programming is a method for finding a maximum or minimum value of some quantity given a set of constraints. So your constraints are the inequalities. So we graphed inequalities yesterday in preparation for this. Limiting the problem at hand. The feasible region is the shaded polygon area created by the intersection of the graphs of inequalities. It is the location where every constraint is met or satisfied. An objective function is a function in two variables, f of x of y. That is the objective to maximize or minimize, such as profit or expense. If a function has no maximum value, the shaded regions of the constraints are unbounded. Since they do not form a closed figure. And all that will make sense when we do this first sketch below. I would not worry about the property vertex principle of linear programming, but what I do find important is actually looking at your process of graphing and determining your maximums and minimums using your objective function. So the first thing that we're going to do is graph each inequality, which the inequalities, as you can see down here, these are going to be your constraints. Actually, all of these are your constraints. They are the ones that are going to create that thing that we call the feasible region. So we're going to graph these four over here, and they should intersect and make a shape. And that shape will have vertices. So we're going to have to determine the vertices of that feasible region. And then we're going to use an objective function, which you don't see here. This one doesn't give you the objective function. And then we will determine the maximum, which is your highest value, or possibly the minimum, which is your lowest value, by substituting the vertices into this objective function. So let's just start by sketching the feasible region. So anytime you have the inequalities, you can sketch just as if it's an equal sign. The inequality itself is for solid or dotted lines and shading. So right here, we're going to graph x equals 3. So remember, if you have x equals a number or y equals a number, it is a vertical or a horizontal line. To determine which one it is, if it says x equals 3, it means your line goes through the x-axis. The only type of line that goes through the x-axis that is a vertical or horizontal would be a vertical line. So I'm going to go ahead and put a point at 3 on the x-axis. So there's 3. And then I'm going to connect that with a line. And assume that my line has arrows on both ends. I'm just not going to bother to put them in there. So that's this function right here. So that one I put in blue. And then the next function, y is equal to 2. We'll deal with the shadings in a minute. Actually, I'll go ahead and shade. I'm going to go ahead and shade just this one time first. And then we probably won't shade after that, but I'm going to go ahead and shade this first one. So it says x is greater than 3. These are the only values that are greater than 3. So all of that. So then I'm going to go to the y equals 2. So you're going to put a point on the y-axis at 2. And the only way to cut through that y-axis is with a horizontal line. So right here. And it says it's greater than 2, so I am going to shade above that line. So now you can see that this is the intersected shading so far for the first 2 constraints. So our feasible region is going to be somewhere in here. Let's sketch the third line. So I'll do that one in green. So I'm going to plot a point at y equals 7. And again, the only way to cross the y-axis is with a horizontal line. So there we go. And then my shading is going to be less than, so it's going to be below this line. So all of this. And then finally, I'm going to graph this line right here. But in order to graph it, I've got to solve the inequality for y. So to get y by itself, I'm going to have to subtract x. And so I get y less than or equal to negative x plus 10. Okay, so that means that my y-intercept is 10, and my slope is a negative 1 because that's the coefficient of x. So I'm going to put negative 1 over 1, or change both signs, 1 over negative 1. So I'm going to plot a point at 10, and then I'm going to go down 1 to the right 1, down 1 to the right, okay, then I'm going to connect that with the straight line. And then my shading for that is less than or equal to, so okay, so I'm going to shade here. All right, so as you can see, the 4 shadings all intersect right here in this area that I'm pointing. So I'm going to go ahead and highlight that area, that region, in yellow. So this is my feasible region right here in yellow. Okay, so my vertices would be right here, and right here. So those are the 3 vertices. Let's see. Oh, never mind. I was trying to erase that little smudge that I made because it's bothering me, but I won't. All right, so we found our feasible region, and the only other thing that we can do right now is to actually write out our 3 vertices. So you might want to put a note here that this right here is your feasible region. And then your 3 vertices would be this one here, which is 3, 2. And then this one here, which is 3, 7. And finally, this one here, which is 8, 2. So now if I actually had an objective function, I would plug these into it to find out which one gives me the maximum value and which one gives me the minimum value. You didn't have that information, so we can't go that far. So let's look at the next problem. All right, so on this problem here, we're going to be testing our vertices. So again, you've been given the constraints, but this time you have a objective function. So once we plot and graph and find our feasible region, we can find those vertices and then plug them into this. So this time I'm not going to shade as I go. I'm going to wait to shade the region, the final region. All right, so let's go ahead and graph. So for my first line, this one right here, I've got to solve it for y. So the first thing I'm going to do is subtract x from each side. So I have 2y less than or equal to negative x plus 9. Then I have to divide by 2, and I get y less than or equal to, take x out of the function, you get negative 1/2 x plus 9/2. So I realize that this is not a lot of fun to graph because my y-intercept is 9/2, which if you change it to a mixed number is 4.5, and my slope is negative 1/2 or 1/-2. But we can still go ahead and plot that, and we are. So I'm going to plot this in red. So I'm going to start at 4.5, which would be right there. So what you're going to have to do is when you plot this slope, you're going to go down one whole step and to the right 2. So from this point, which is halfway in between the two vertices, you're going to go one whole step, which puts you halfway in between 3 and 4. So this is down 1 and to the right 1, 2. So you're going to plot a point right here. So right here. Whoops, I'm a little low. And then you're going to do it again. So you're going to go down from here, you're going to go down 1 to the right 2, and keep doing that until we get down to the edge. Typically with linear programming, we stay in the first quadrant. Oops, I totally missed that one. Let's try that one again. Okay, so I'm going to connect those with a line. All right, so that's going to be close enough. Now our shading for this, when we get there, will be in this direction below the line. So somewhere in here is our feasible region. All right, our next line is going to be this one. So I'm going to subtract x from both sides, so I have negative y less than or equal to negative x plus 3. So then we have to divide everything by a negative 1. As soon as you divide by a negative 1, this sign is going to flip. So we end up with y, instead of less than or equal to, we have greater than or equal to. 2 negatives make a positive x, and then minus 3. So my y-intercept is negative 3, and my slope is equal to 1/1 or negative 1/-1. So I'm going to plot this one in blue. It's much easier than the last one to plot. So because we have to start at negative 3, this is going to be negative 1, negative 2, negative 3. So I'm going to start down here, and I'm going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right, okay, and then plot my line. Now this one, remember we flipped the sign, so the shading for this one is up in this direction. So that means that right now, this is where the two shadings would intersect. All right, then the rest are easy. We're going to graph this line, x equals 0. So that's where x is 0. The only way to cut the x-axis at 0 is with a vertical line. So there's my vertical line. Okay, then it says that it is greater than, so we would be shading to the right. So right now, this looks like my feasible region. And then finally, I'm going to graph, let's graph this one in yellow. So I'm going to graph y is, I can't read my paper. Oh, y is greater than or equal to 1. So I'm going to plot 1 on the y-axis and then put my line there. Horizontal line will cut that y-axis. Okay, and it says greater than, so our feasible region is going to be right in here. So I'm going to plot my vertices. So here's 1, here's 1, another 1, and another 1. So these are my vertices right here. So let me shade in that region. So let's see, I'm going to shade. Okay, so there's our feasible region. So now I want to find those vertices. So I'm going to write or create a table of values. So I've got x, y. And then I have p equals 3x plus y. And then that's going to give us our p, our profit, probably is what that means. So our first ordered pair over here, right here is, goodness, so that one is 0, 1, okay? So we're gonna go ahead and plug that in. So I've got 0, oops, get my pen. So 0, 1. And we're gonna plug that into here. So 3 times and then plus. So 3 times 0 for the x and 1 for the y. So that means that my profit is 3. My next ordered pair is here. And so this is 4, 1. So I'm going to plug in 4 and 1 in here. 4 for x, 1 for y. 4 times 3 is 12, plus 1 is 13. So far that's the biggest. Then our next vertex is right here, and so that is 5, 2. And so 3 times 5 plus 2. So 3 times 5 is 15, plus 2 is 17. And then last but not least, our last vertex is here, and that's going to be 0, 4.5. So I'll put 4.5. So 3, 0 plus 4.5 is going to give us 4.5. All right, so then look at your values here, 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 and here. This is the only one that gives us the highest value. So this is your maximum. So therefore, 5, 2 is the maximum point. And that's all you have to do. So then, example 3, I want you to try on your own. It's just exactly what we did. So I'm going to quietly do it here. You're going to stop the video, do it, and then restart the video and check your answer. So there's your feasible region. And then these are your vertices. Here, 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 and here. So now we're going to create our table of values. We're going to put our objective function here. All right, so our first ordered pair right here is 0, 0. So if I plug that in, we are going to have a value for n of 0. No shock and surprise there. All right, our next ordered pair is 0, 8 right here. So let's try that one. So 100 times 0 is 0, plus 40 times 8 is 320, and then add 0 to that, you still get 320. So far that's the biggest. Then our next ordered pair is 2, 6. So right here. So we're going to plug that in. So plug in 2 and 6. So 100 times 2 is 200. 40 times 6 is 240. And if you add those together, you get 440. So far, that's the biggest. And then last but not least, we have this vertex 5, 0. So 5 times 100 is 500, plus 40 times 0 is 0. Add them together and you get 500. So clearly, this is our max. So therefore, the max is at 5, 0. So the max is 500 at 5, 0. Let's add on to this. So this time you have to create your own inequalities for the constraints, and you have to write your objective function. So it gets a little bit more difficult. So read the problem first and highlight things as you go. So a baker earns 15 cents profit per glazed donut G. So that would be important. So I'm going to highlight 15 cents per glazed donut. And 40 cents per jelly donut. So again, something important. If a customer wants to buy no more than, that sounds like a constraint. It's keeping us from doing everything we want to. So if a customer wants to buy no more than a dozen donuts, so let's highlight that constraint. And wants to try at least one of each kind, so there's another constraint. What is the maximum profit? So here comes your objective function, because it's the question, what is the maximum profit the baker can earn? So our objective function is going to be maximum profit. So to get our profit, P for profit, it's going to equal 15 cents times G, the number of glazed donuts, plus 40 cents times J, the number of jelly donuts. So that is our objective function. Then our constraints are as follows. If a customer wants to buy no more than a dozen donuts, so your G, number of glazed, plus J, your number of jelly, can't exceed a dozen, so that has to be less than or equal to 12. Okay, then the customer wants to try at least one of each kind, at least one. So that means the number of glazed donuts that they're going to select has to be greater than or equal to 1. You don't want to do 0 because that would imply less than 1, and they have to try at least 1. And that goes for your jelly as well. Your jelly has to be greater than or equal to 1. So these are your constraints. Whoops, about to spell it wrong. Okay, and then I want to define my variables, so I'm going to let G equal number of glazed, and J equal number of jelly. Okay, so let's go ahead and graph these. So the only one that we really have to solve is this one. And since we don't have an x and a y, you have to figure out what's going to be what's going to be x and y. So make a choice. Let's let G be our x and J be our y. Okay, so that means I'm going to solve this equation for J. So J is less than or equal to negative G plus 12. So I'm going to start at 12. And it's slightly off right here. And I'm going to go down 1 to the right 1. All the way down. Then I'm going to connect that with a straight edge. Okay. Then I am going to graph G is greater than or equal to 1. So I'm going to put a point on the G axis at 1. The only way to cut through that G axis is with a vertical line. And finally, I'm going to graph J is greater than or equal to 1. So I'm going to put a point at 1 on the J axis, and the only way to cut the J axis is with a horizontal line. So that means that our feasible region, if this line is less than or equal to, I'm shading down in this direction, and the blue line is greater than, I'm shading in this direction, and the green line is greater than, I'm shading in this direction. All three of those shadings make this triangle. So this is my feasible region, meaning that any ordered pair within this region matches the constraints that I'm looking for Okay, so then we have to find our vertices. So this is one vertex, a second vertex, and a third vertex. So let's set up our chart or table to find our maximum profit. So I'm going to do GJ. Oops. Okay, there we go. And then P equals and then that's going to give me big P. Okay. So our first ordered pair, or our first vertex is at 1, 1. So I'm going to plug that in. So 15 cents plus 40 cents is 55 cents. Our next vertex is at 11, 1. So 11 glazed, 1 jelly. Getting hungry for donuts. So 0.15 times 11 is $1.65 plus 40 cents gives you $2.05. So far that's the biggest, but we have one more to look at. And that would be 111. So 1 and 11. So we have 15 cents plus 40 times 11 is 440. So that gives us $4.55. So there's our maximum right there. So therefore, maximum profit is $4.55 for 1 glazed and 11 jelly donuts. All right, so then I'm going to leave you to do example 5 on your own. So pause the video, you do it on your own, and then start the video back up. I will talk you through your solution. So Josh has 40 minutes to complete a government exam. There are 12 multiple choice questions worth 5 points each. There are also 5 short answer questions worth 8 points each. It takes about 2 minutes for Josh to answer the multiple choice questions M and about 8 minutes to complete the short answer questions S. Josh is trying to figure out how many of each type of question he should answer to maximize his score. So, the things that I don't know, and they've kind of pointed you towards it, would be the number of multiple choice questions, so we're going to let M equal that, and the number of short answer questions, we're going to let S equal that. I don't have room on here to, pardon me for yawning, to write out my definition, but that's what they are, okay? So then let's look at the constraints. All right, so constraints. So let's reread this and look for some things that will tell us what constraints we might have. So Josh has 40 minutes to complete an exam. So he's limited on time. There are 12 multiple choice questions worth 5 points each. So 12 multiple choice worth 5 points each. Oh, we also have to come up with our objective function. So that's going to be actually part of our objective function, and there are 5 short answer questions worth 8 points each, because that's going to give us our total points, and we are trying to maximize his score. So to find his score, we're going to use those items. So I'm going to use the 12 multiple choice worth 5 points each and the 5 short answer worth 8 points each to get that maximum score. So we'll come back to that. Then it takes about 2 minutes for Josh to answer the multiple choice questions, M, and about 8 minutes to complete the short answer questions. So that's going to go along with his time constraint. So it takes 2 minutes for Josh to answer the multiple choice and 8 minutes to complete the short answer. So let's write a constraint towards that. So he's only got 40 minutes to take the test. So that means that he's going to spend All right, so he's going to spend 2 minutes on a multiple choice for each multiple choice, and then we're going to add to that the 8 minutes that he's going to spend on each of his short answers. That has to be less than or equal to 40 minutes. So there's his first constraint, is time. Then his second constraint is going to be the types of questions, because the question says Josh is trying to figure out how many of each question he should answer to maximize his score. So there are 12 multiple choice questions and 5 short answer questions. So he's going to have to answer. So here's his multiple choice. So he's either going to answer all 12, so he would answer less than or equal to 12, but he's definitely going to have to answer greater than or equal to 0 of them, because there's not any negative multiple choice questions. So he's got to answer somewhere between 0 and 12. Then for his short answer, he only has 5 short answer questions. So he's got to answer less than or equal to 5, but greater than or equal to 0, because he has to answer somewhere between 0 and 5. Then let's go ahead and write, before we graph these, our objective function. So the objective function is going to be, so his maximum score, so let's use, I hate to use S when we already have S for short answer, so I'm just going to put score equals. So to get his score, he's going to answer multiple choice questions, I don't know how many, and short answer questions. So the multiple choice questions are worth 5 points each. So he would get 5 points for every multiple choice question he answered, and then you'll add to that. The short answer questions are worth 8 points each. So that should get us everything that we need. So I am going to solve this equation right here for, let's put M here. I'm going to put M here, and I'm going to put short answer here. So that means I want to solve for S. So 8S is less than or equal to, now I'm going to subtract 2M, so negative 2M plus 40, and then divide everything by 8. Okay, so I end up with S less than or equal to negative 2 over 8 reduces to negative 1 over 4 M. 40 divided by 8 is 5. So there's 5, and I'm going to go down 1 to the right, 4. Okay, connect those. Then I am going to graph this. Really what I'm graphing is this. M is equal to 12. So here's 12. 1, 2, 3, 8, 9, 10, 11. So here's 11. And here's 12 right here. So I'm actually going to go right through there. Okay, so really I'm graphing from 0 to 12 with an arrow here. Well, technically, yeah, with an arrow there, so that's good. We're just going to stop there. Then I'm going to graph this. S is equal to 5. So it's right here, but I have to have a horizontal line. And technically there's an arrow here, but we're really only going up. Okay, so let's look at where we would shade. So for this equation right here, it's still less than, so we're going to shade below right here, right here. And then this blue one is less than, so we're going to shade in this direction. And then this less than 5 is down here, so we're shading down here. We really didn't need this one, but it's okay. So our feasible region is right here, because we're stopping at the zeros because of this right here. So we get this funky shaped figure. So technically, if you wanted to, you could have put, the blue line is here at 12, you could put a blue line here at 0 to go from 0 to 12. The green line here is at 5. If you want to go from 0 to 5, you could have put a green line here at 0 and 5, shaded in between. But the X and Y axes act as those barriers. So we're going to go with it. So our vertices are here, 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 and here. So we have 4 of them. So I have MS. And then we're going to put in 5M plus 8S and it's going to give me a score. Okay, so here we go. Our first vertex is the 0, 0. So of course we would have a score of 0, which we definitely, hopefully that's not your max. Then our next vertex is 0, 5. So we're going to plug in 0 and 5, which is going to give us 40. Well, that's better. We can do better than that. Then our next vertex is 12, 2. So 12 and 2. So 5 times 12 is 60, 8 times 2 is 16. Add those together and you get 76. Our last ordered pair is 12, 0. So you answer all multiple choice and no short answer. Let's see how that's going to do for you. So 12, 0. And 12 times 5 is 60. Clearly that's not the best. So this right here is your maximum. So therefore, your max score is 76 if Josh answers 12 multiple choice and 2 short answer. Just leave it at short because I just ran out of room. Okay, last problem. So in this problem, we're going to read first to figure out our constraints, figure out our objective function. Actually, they gave us our objective function. Yay, hooray. So here it is, right here. They gave us our objective function, and they defined our variables for us right here. So a small company has 5 3-ton trucks and 4 5-ton trucks for hauling gravel. So that's where we got the 3 and the 5. X is the number of 3-ton trucks. Y is the number of 5-ton trucks. So 3 tons times the number of trucks. 5 tons times the number of trucks should give you your total tons that those trucks are carrying. So that's what your objective function is telling you, is the number of tons of gravel that's hauled per trip. So here comes your constraints. So I'm going to highlight those important features. So 5 3-ton trucks and 4 5-ton trucks. Then our constraints are only 7 crews are available at any one time to operate the trucks. How many of each kind of truck should be used to haul the maximum amount of gravel per trip? So we really only have more than one constraint, but we'll talk about that here in a minute. So we have our objective function. So let's look at our constraints. So our first constraint is the one that I've already highlighted, is right here. Only 7 crews are available at any one time. So if there's 7 crews, the number of trucks that are hauling the gravel, we can only have a total of 7 trucks or less. So this number plus this number has to be less than or equal to 7 because you don't have enough drivers. So that's our first constraint. X plus Y has to be less than or equal to 7. Okay, so then our next constraint is going to be dealing with the number of trucks that hold the amount of gravel. So we've got 5 3-ton trucks. So we can only have the number of 3-ton trucks is limited to 5. So we have to start off with saying, well, we might have 7 crews available, but X, which is the number of 3-ton trucks, has to be less than or equal to 5, because we only have 5 of those. And so then that means that our other restriction has to be the fact that we only have 4 5-ton trucks. So the number of 5-ton trucks is limited to 4. So Y has to be less than or equal to 4. All right, so we have that and our objective function. So we're ready to go. So let's graph this one right here. So to solve for Y is less than or equal to negative X plus 7. So we're going to start off at 7. So right here, we're going to go down 1 to the right one, all the way across. Okay, connect your points. And then that, of course, is less than, so we're somewhere around here. Then I'm going to graph this one in blue. So on the x-axis, I'm going to plot 5 right here. To cut the x-axis, that would be a vertical line. And of course, we're less than, so we're somewhere over here now. And then finally, I'm going to graph y is less than or equal to 4, so plot 4 on the y-axis. The only way to cut that y-axis is with a horizontal line. And that one is also less than, so this now is our feasible region. Because again, we can't have negative trucks, so we know that we're dealing with a positive world here. So our feasible region looks like this right here. Okay, our vertices are here, 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 here. Remember, those vertices define the shape of that region. So I've got 5 vertices. So here we go. All right, our objective function is 3x plus 5y, and that is going to give us tons, which is tons of gravel. Okay, so our first ordered pair is 0, 0. So we're going to plug that in. And of course, we get, if we don't have any trucks out, we're not going to move any gravel. So that one's 0. Our next ordered pair is 0, 4. And so let's plug that in. Zero and 4. And so that's going to give us 20. Our next vertex is 3, 4. That's a 3. So that gives us 9 and 20, so 29. Then we have 5, 2. Plug in 5 and 2. So we have 15 and 10, which is 25. Definitely not a maximum. And finally we have 5, 0. 3 times 5 is 15. So this is our maximum right there. So therefore, maximum is 29 tons of gravel using 3 small trucks and 4 large trucks. And there you have it. If you have any questions, don't hesitate to ask.